Hello students! In this video we're going to look at rational expressions. We're going to learn how to simplify them and eventually get to multiplying and dividing them. First question is, what is a rational expression? So I'm going to scroll for a second. This and this and this, all these problems are example of rational expressions. So basically what it is just some sort of fraction with the numerator and denominator being polynomials. That's a definition you may want to write down, although I'm not. Now the reason I have all these number fractions here is because the rules of simplifying rational expressions are the same as the rules of simplifying any regular old fraction. So for example, if I look at these two problems, this versus this, what can we simplify and what can we not? So in this problem we have 3 plus 2, which is 5, over 3 plus 7, which is 10. So if you wanted to simplify that, you'd have to divide both by 5 and get that this is 1/2. So a lot of people, when we're doing rational expressions, like to cancel out these factors of 3. But you can't do that because they're together with that plus sign. So you have to add first, then simplify. And if you look at 5/10, you can't take a factor of 3 out of both of those. So you cannot cancel those 3's when there's a plus sign there. Whereas this problem, can you cancel the 3's? So 3 times 2 is 6. 3 times 7 is 21. And 6 and 21 both have a factor of 3. So when you're multiplying, you can cancel because you're canceling out a common factor that you would just divide by here. Division and multiplication undo each other. So keep that in mind, that in this first example you can't simplify. In this second example, you can simplify. Other rules that apply, when can you divide fractions? Think about how you would clear this fraction. You'd have to multiply by the reciprocal. Reciprocal meaning you flip it. So these would all cancel. You'd be left with 1 in the denominator, and then you just multiply by the reciprocal to divide the fractions. Okay, I went through those rules quickly because I'm assuming they're things we've heard. If you're not comfortable with fractions, you may want to review those before getting into rational expressions. I'm going to refer back to those rules as we go on throughout, though. So if I look at something with polynomials, now if I want to simplify this, the only thing I can do is simplify when I have multiplication, like I did here. So how can I turn a polynomial into some multiplied term? And the answer is you always have to factor to start these problems. Okay, when you factor something, we learned in last chapter that you're breaking it down into a product. So at the end I should have something times something else. Okay, over something times something when I factor the denominator. And since this means you're multiplying, then we can cancel common factors, just like here I can cancel the common factor of 3 when it's being multiplied. So very first step in simplifying is you're going to want to factor. So this is where the last part of the chapter comes in handy. X squared minus 9, I'm not going to talk about factoring in depth, but this is a difference of squares. So there's a difference, this is perfect square, this is perfect square. So I know difference of two squares factors to be the same two terms but opposite side in the middle. Square root of x squared is just x and x. Square root of 9 is 3 and 3. And you can check that. So x times x gives me x squared. My outers and my inners will cancel. And my last, negative 3 times positive 3, will give me that negative 9. Again, it's important to become quick and efficient with factoring because we're going to use it as a tool to advance us in these rational expressions. So keep practicing that. Okay, this one may take a little guess and check. I prefer to do guess and check rather than AC method because I need to do these factoring parts quickly so I can get to the more complex math. So guess and check to refresh our memory. Your first two terms need to multiply to be the first term. So the only thing that multiplies to be 2x squared is 2x and x. Now my last terms need to be multiplied to negative 3. So the only options are negative 3 and 1 or negative 1 and positive 3. So I'm just going to check. So let's say I put negative 3 and positive 1 here. I'm going to distribute to see if that works. So my outers and my first and my last, 2x times x gives me 2x squared. My last, negative 3 times 1 gives me negative 3. Okay, I just really need to check my outers and inners. So I get 2x on the outside and negative 3x on the inside. If I combine these, I'll get negative x, which does not add to this positive 5. So my gut is telling me that these numbers aren't working where they are because they were so close together and give us a 1. So I'm going to switch them and see what happens. My outers here give me, let's see, that's not 3, that should be 6x. My inners give me negative 1x. And when I add those together, luckily I checked pretty quickly, but that will give me a positive 5x. If you got a negative 5x, you know you just have to switch the sign. So now that I've factored these pieces, I can cancel anything that has a common factor in the numerator and denominator because they're being multiplied. So really what this problem is saying, or I could break this up into be x minus 3 over 2x minus 1 times x plus 3 over x plus 3. The reason I can do that is when you multiply fractions, you just multiply across the top and across the bottom. So really that's an equivalent expression. I just separated it. And what's x plus 3 divided by x plus 3? Well, what's 3 divided by 3? Anything divided by itself is 1. So you can cancel that common factor of x plus 3, or I could have done it here. So our final answer is I have x minus 3 over 2x minus 1. You can't simplify the x's here because they're separated, or I guess you could say the 2x and the 1 are combined with that subtraction sign. The x and the 3 are combined with that subtraction sign. You cannot separate them from the rest of their friends there. So this would be my final answer. So you can't simplify here. Again, you can simplify in a situation like this. Now the problems get a little bit more challenging if you're dividing or multiplying. Now, the good news is dividing and multiplying are almost the same thing. So going back to this problem, if I want to divide fractions, that's really like multiplying by the reciprocal. So everything you see as a division problem, I want you to rewrite as multiplication. So this problem is the same thing as saying, well, this first fraction is the numerator. And I know there's multiple fraction signs, but let's look at this big fraction. This is the numerator, this is the denominator. Instead of dividing by the denominator, that's really the same as multiplying by its reciprocal. So we have 6x to the third minus 6x squared plus 6x in the numerator now. And the denominator will be our 3x to the fourth. So the good news is if you do this, then it becomes a multiplication problem, which division and multiplication are then handled the same way. I do want to reiterate why this works. So if you're dividing 3/4 divided by 2/3, if I multiplied by the reciprocal of the denominator, what would happen is everything would cancel here, and you'd get 1 in the denominator. And whatever you do to the bottom, you have to do the top. So I'd multiply the top by the reciprocal as well. So you just get this problem as being equivalent. If you have more questions about that in class, feel free to ask. Anywho, now that we have a multiplication problem, after you rewrite as multiplication, I want you then to factor to see what you can cancel. So we're going to factor this, starting with this piece here. On the numerator, all you can do is take out a GCF. So you have x on the outside. X times x gives you x squared. X times, well, it's got to be positive 1 to give you the same thing here. Denominator. Can't factor a GCF out. There's 2 terms. I'm going through my factoring checklist. It's a sum. It's got to be a sum of perfect cubes. So perfect cubes, the signs are the same. Then you have the opposite sign, and then always positive. Now, the first term is the cube root of your first term. So cube root of x cubed is just x. Then take the cube root of your second term is just 1. Now plug them into the formula where you square it, multiply them together, and then square the last term. So if you square x, you get x squared. You multiply them together, you get 1x. And you square the last term, you get 1. So that one's just a cubes. And if you know the formula, it makes these problems a lot quicker, so make sure you're working on that factoring and become masterful in that. Same thing here, I can take out a 6x as my GCF, then what's left over, it'd be x squared minus, let's see, there's only 1x left, no 6's, and then you took out everything, so you just have to multiply it by 1 to get that original polynomial. In the denominator, you can't cancel anything at all, or excuse me, factor. So now, let's think about what multiplication means. Like I said in the beginning, when you multiply fractions, you're just multiplying across the top, and you're also multiplying across the bottom. So technically, I could rewrite this as one big fraction that looks something like this. So really, I'm multiplying x times x plus 1 times 6x times x squared minus x plus 1. Really, all of these things are being multiplied together. You can put a multiplication sign if it makes you feel better, but it doesn't really matter because you can just write next to each other. Same thing in the denominator. These are being multiplied together, and so is this 3x to the fourth. Everything is being multiplied, so you can either write it as 2 fractions or 1. And once you write it as 2 fractions, this is very similar to the problem we did before, where anytime you see a common factor, or you're dividing something by itself, you can cancel it because it's just a 1. So things you can cancel, let's look. Notice I have this polynomial twice, so that can cancel. I have an x plus 1 twice, so x plus 1 divided by x plus 1 is just 1. Now, I'm just going to rewrite this so we can see what's happening more. What's left here is you have an x, a 6x, and a 3x to the fourth. So if I combine these, x times 6x is 6x squared. On the bottom, we just have the 3x to the fourth. Is this simplified? Wait time. Hopefully you're all shouting, no way, because we've worked on this, and we worked on exponent rules. So first things, numbers you can take care of. 6/3 is actually just 2. Now, for the variables left, I have 2 x's on top, 4 x's on bottom. If you subtract the exponents, you'll get -2, which -2 will then drop to the bottom. But that's really unnecessary if you think about expanding it. So if I have 2 x's and 4 x's, I can cancel 1 x here and cancel 1 x here, and all that's left is 2 x's in the bottom. So this would be your final answer from the original problem. It's almost funny if you think about it, but what I like about that is you can take something so complex and break it down into pieces and simpler parts and come up with a simple solution. So I know we didn't get to this last one, but it's multiplied. So I went through all the steps you need to try this, and I want you to try it on your own and self-assess. Do I understand? Am I an M? Do I need some help? Am I an A or a T? Or do I have no idea what's going on? And then please come in for extra help. Otherwise, have a good night.